Hey, I'm Jacob and welcome to Elektrobox. For my next ESP32 project I need to convert a 3.3 volt logic signal into a 5 volt logic signal. So in this video I will show you the basic principle of a simple logic level shifter using two N-channel MOSFETs. The MOSFETs must be suitable for logic level operation. This means they should already switch reliably with a gate voltage of around 3.3 volt. A quick disclaimer before we start. For fast or timing critical signals, dedicated level shifter ICs are usually the better solution, but for slower GPIO signals, the simple MOSFET circuit can be useful. Now let's look at the schematic. The 3.3 volt signal from the ESP32 is connected to the gate of the first MOSFET through a 1 kilo ohm resistor. The source of the MOSFET is connected to ground, the drain is connected to 5 volt through a 10 kilo ohm pull-up resistor. The voltage at the drain is our output signal. When the ESP32 output is high, the MOSFET turns on. Current can flow from the 5 volt supply through the pull-up resistor, through the MOSFET and down to ground. Because of this, the drain voltage is pulled down to 0 volt. When the ESP32 output is low, the MOSFET turns off. No current flows through the MOSFET, so the 10 kilo ohm pull-up resistor pulls the drain up to 5 volt. So the first stage converts the signal to 5 volt, but it also inverts it. Input high becomes output low, input low becomes output high. To get the original logic back, I add a second inverter stage. The output of the first stage drives the gate of the second MOSFET. Again, the source is connected to ground and the drain is pulled up to 5 volt through another 10 kilo ohm resistor. Now the signal is inverted a second time. This means the final output follows the original ESP32 signal again, but now with a 5 volt logic level. So with these two MOSFETs inverter stages, we can build a simple non-inverting level shifter from 3.3 volt to 5 volt. Now let's check the circuit in LTspice. I recreated the schematic and added a pull-down resistor at the gates. These make sure the MOSFET gates are pulled cleanly to ground when no active signal is applied. In the simulation we can first see the original 3.3 volt input signal from the ESP32. At the output of the first MOSFET stage, the signal is shifted to 5 volt, but it's inverted. After the second MOSFET stage, the signal is inverted again. Now the final output follows the original input signal, but with the 5 volt logic level. So the simulation confirms that the circuit works as expected. But there are some limitations. Because the circuit uses 10 kilo ohm pull-up resistors, the rising edges are not very fast. The signal does not switch instantly from low to high. The speed depends on the pull-up resistors and the capacitance of the circuit. This means the circuit is not ideal for fast SPI, high frequency PWM or timing critical LED signals. For slow digital signals, enable pins or basic GPIO level shifting, the circuit can work well. But for fast signals, use a dedicated logic level shifter IC. And that's the basic idea behind the simple MOSFET logic level shifter. If you want to learn more about MOSFET, pull-up resistor, digital signals and other electronic basics, check out the learning section on elektrobox.ch. Thanks for watching and see you in the next Elektrobox project.